Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 7, Unit Rate as the Constant of Proportionality. Okay, so classwork says, Example 1, National Forest deer population in danger, question mark. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16 square mile area of the forest. So there's our first bit of information. In another part of the forest, conservationists counted 117 deer in a 13 square mile area, yet a third conservationist counted 216 deer in a 24 square mile forest. Do conservationists need to be worried? Do they need to be worried? So A says, why does it matter if the deer population is not consistent in certain area of the national forest? Okay, so we discussed this in class, and there are many possible theories. Okay, amount of food, that's one. Overpopulation, hazards. You know, how many roads go through that area? Deer often cross roads. Deer often get hit by cars. There's all kinds of other issues. Foresting, cutting trees down, that sort of thing. So just list a bunch of things that would make the population not constant is what that is saying. Now B says, what is the population density of deer per square mile? Per square mile means we want to figure out how many deer total there are, how many square miles total, and then determine what our average number of deer per square mile are. So if I were to set up a table and say, oh, square miles, and number of deer, and then finally we want to find our, and as we go to the name of this constant of proportionality, okay, we're looking for the constant of proportionality. If we read this, 16 square miles of forest, 144 deer. 117 deer in 13 square miles, and then finally 216 deer in 24 square miles. So those are the three values we have, and in order to find the constant of proportionality, if this was our x and this was our y, k, constant of proportionality, equals y divided by x. So it'd be 144 divided by 16, which equals 9. To find this one, it would be 117 divided by 13, and that also equals 9. And then finally, if we take 216 square miles divided by 24 square miles, 216 deer divided by 24 square miles, we get 9 again. So the unit rate of deer per 1 square mile is 9. So for every square mile, there are 9 deer. The constant of proportionality is, well, that's our k equals y over x, and we'd just simply say k equals 9, because all three of these, y over x, give us the same value. So there does exist a constant of proportionality. They are all the same, and that number is 9. And then it says, explain the meaning of the constant of proportionality in this problem. Okay, so what you would say is there are 9 deer for every square mile. That's what the constant of proportionality means here. For every square mile, there are 9 deer. C says use the unit rate of deer per square mile, or y over x, to determine how many deer there are for every 207 square miles. So what they're saying now is you have 207 square miles. That is going to be our x. Use the unit rate, k, which equals 9. So if we say k equals y divided by x, that's our equation, and we know x is 207 and k is 9, then we can say 9, replacing k, equals y divided by, that's a pretty bad y divided by x, and x is 207 square miles. Okay, so in order to find y, we need to get rid of this 207. And in order to solve for y, we need to do the inverse operation. Y divided by 207. The inverse of division is multiplication. So if I multiply the right by 207, let's just say 207 over 1, then I must multiply the left by 207 to keep the equation even, or equal. So these 207s cancel, and then we end up with y equals all by itself, and then just simply multiply 9 times 7 is 63, and 9 times 2 is 18. So 207 times 9 is 1,863 deer would be in that 207 square mile area. D says use the unit rate to determine the number of square miles in which you would find 486 deer. So now I'm going to use that same equation. K equals y over x. We already know k is 9, so I'm going to replace that with 9 equals, and now we know deer, which is our y, and so we put 486 in place of our y, and we're trying to solve for x. We can do this in 2 steps, but there's also a shortcut, but let's just do the 2 steps for now. I won't confuse you with the shortcut. In order to get this 486, we have to get x out from underneath a fraction, so I'm going to multiply both sides by x. These x's will cancel, and then this will result in 9x, 9 times x, equals 486. I don't like working horizontally, but I have no choice with this in the way down here. I like working vertically, but I have no choice here. So 9x divided by 9, now we're trying to find out what x is, so if I divide both sides by 9, these cancel, and we get x equals, and 9 goes into 48, 9 times 6 is 54, 9 times 5 is 45, so 5, 45, remainder 3, and 9 will go into 36 4 times. So the answer is 54. And what is that? Use the unit rate to determine the number of square miles. It would be 54 square miles. 54 square miles would have 486 deer living there. Okay, so now we're talking about vocabulary. A variable is a symbol, such as a letter, that is a placeholder for a number. So if I go back here and show you, I've been doing that. We have equations here with x's and y's and k's, and those are all variables. So when I say there's 207 square miles and my square miles is x, then I can take this x and replace the number placeholder for a number with that number 207. So these are called variables. If a proportional relationship is described by the set of ordered pairs x comma y that satisfy the equation y equals k times x for some number k, then k is called the constant of proportionality. It is the number that describes a multiplicative relationship between measures x and y of 2 types of quantities. The x-y pairs represent all the pairs of numbers that make the equation true. If I plug an x in and I don't get a y out that makes the equation true, then I did something wrong, or it is not in proportion. It's not a proportional relationship. And then note, it says, in a given situation, be reasonable to assign any variable as a placeholder for the given measure. For example, a set of ordered pairs t comma d would be all the points that satisfy the equation d equals r times t, which means distance equals rate times time, where r is the constant of proportionality, our rate, and the value for r specifies a number of a given situation. Okay, example 2. You need what? Brandon came home from school. Oh, this should be, you need what? That's how a parent would respond to this. Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade level. He needs 3 cookies for each of the 96 students in 7th grade. So I'm going to stop right there. There are 96 students in 7th grade. Each child is going to get 3 cookies. 6 times 3 is 18. 9 times 3 is 27, plus that 1 is 28. He needs 288 cookies. That's a lot of cookies. Okay, so that's the first thing we needed to do. 3 cookies per person. How many cookies do you need total? So now, unfortunately, he needs the cookies the very next day. Brandon and his mother determined that she can fit, or they can fit, 36 cookies onto 2 cookie sheets. So there's our next 36 cookies onto 2 cookie sheets. So if I'm thinking about that and I can get 36 cookies on 2 cookie sheets, then I can get 18 cookies per sheet. Okay, assuming the 2 sheets are equivalent in size. A, is the number of cookies proportional to the number of cookie sheets used in baking? Create a table that shows data for the number of sheets needed for the total number of cookies baked. So here we need to create a table. So we're going to have number of cookies, and we're going to do, or not cookies, cookie sheets here, and number of cookies, and then we're going to do our constant of proportionality, which is k. I'll just write k this time because we all know what that is. So for starters, we knew that they were giving us 2 cookie sheets, gave us 36 cookies, and the constant of proportionality would be 36 divided by 2, which equals 18. So I already did that over here, but we should show it in our table. So then, remember, multiplication's repetitive addition, so 2 plus 2 is 4, or 2 times 2 is 4. And 36 plus 36 is 72, or 36 times 2 is 72. And when we have 4 cookie sheets, we can make 72 cookies. 72 divided by 4 is also 18. Okay. And we continue on in this fashion. And we need 288 cookies. So if I continue with this, now let me just use, let's say 6. That was 2 times 3. 36 times 3 is 18. 6 times 3 is 18. And 3 times 3 is 9, plus 1 is 10. That would be 108. So therefore 108 divided by 6 equals 18. And we could go on and on and on and on until we come up to our number, but that's not necessary now that we have a pattern. If I am going to find a constant of proportionality and it is 18, then I am multiplying 2 times 18 to get this. So y, this is y, equals k, 18 times x. Y equals k times x. Y equals k times x. And y equals k times x. And I don't know that value. So I'll just leave that for now. Actually, no, let's finish it now. If this is 18 times x equals 288, what I'm trying to point out here is 2 times 18 is 36, but if I go the other direction, 36 divided by 18 will give me 2. 72 divided by 18 will give me 4. 108 divided by 18 will give me 6. So if I take 288, divide it by 18, that will give me number of cookie sheets. 18 will go into 28 once with a remainder of 10. And so I'll put that here, and then we're down to 108. 18 goes into 108 5 times, or 6 times. 6 times. So the answer is 16. So this value here, I will erase now. This x now is going to be 16. So we need 16 cookie sheets to make 288 cookies. The unit rate of y over x is 18. Constant of proportionality is k equals 18. Explain the meaning of the constant of proportionality in this problem. Okay, so there are 18 cookies per cookie sheet, or you could say for every cookie sheet there are 18 cookies. B, it takes 2 hours to bake 8 sheets of cookies. If Brandon and his mother begin baking at 4, when will they finish baking the cookies? Okay, so first of all, we need to use this information here. So let me just drag that down here because it's off the screen now. Here's what we need. We need 288 cookies. 96 students times 3 is 288. Okay? So we need 288 cookies. And we're going to divide by 18 cookies per sheet. Okay? We're going to divide by 18 cookies per sheet. And when I take 218 divided by 18, 288 divided by 18, we already did it here, we get 16 sheets. If Brandon and his mother begin baking, and it takes 2 hours to bake 8 sheets of cookies, okay, so if it takes 2 hours to bake 8, it will take how long to bake 16? Well, 8 sheets to 16 sheets is double, so it's going to take 4 hours to bake 16 sheets. So this is a 4-hour process, and they begin baking at 4 p.m. So 4 p.m. add 4 hours, they will finish at 8 o'clock p.m. They will finish at 8 p.m. Okay. Example 3, French class cooking. Suzette and Margot want to prepare crepes for all the students in their French class. A recipe makes 20 crepes with a certain amount of flour, milk, and 2 eggs. So a recipe makes 20 crepes, and one recipe that makes 20 crepes requires some milk, some flour, but they were specific on the egg amount, which is 2. The girls already know they have plenty of flour and milk to make 50 crepes, but they need to determine the number of eggs they will need for the recipe because they are not sure they have enough. So we want to set up a proportion here. So right here, 2 eggs will make 20 crepes, so I'll write that. 2 eggs for every 20 crepes. Okay? That would equal 1 egg. We're getting down to 1 unit would make 10 crepes. One egg, 10 crepes. The constant of proportionality then is right here. K equals 1/10. What does the constant of proportionality mean in the context of this problem? One egg is needed to make 10 crepes. How many eggs are needed to make 50 crepes? Okay, well, if I use the equation y equals kx, where k is our constant of proportionality, I can now substitute that in, and our k is 1/10 x. How many eggs? So we want to know y. So y equals 1/10 times the number of crepes we're making. So that's 50. So y equals 1/10 times 50 is 50 divided by 10, which is 5. We need 5 eggs. That is the end of lesson 7. The lesson summary says, if a proportional relationship is described by the set of ordered pairs xy that satisfies the equation y equals kx for some number k, then k is called the constant of proportionality. Go do your problem set.